Salutations, my little triglets. Welcome to Chapter 4. Chapter 4 has to do with logs and exponential functions. So we're going to start out, Section 4.1 is exponential functions. Now I know you had a little experience with these functions in Algebra 2, so hopefully it won't be totally new to you or foreign. The basic formula is y equals b to the x, where b is the base. Whenever we talk about the base, that's the letter b in our formula. So let's look at a equation here. Y equals 42.2 1.56 to the x. And believe it or not, this function represents the average money spent after X hours of browsing in a mall. So, oops, there's a W in there, browsing in the mall. So people say, oh, can I help you? And you say, no, I'm just browsing. And they're fine with that because they know the longer you stay, the more likely it is that you're going to buy something. So X is an exponent. That's what makes this an exponential function. Exponential functions usually rise very quickly. And so if X is the time spent, then this would be the money that you spend. So the longer you stay, the more money you're going to spend. Now, there are several rules for an exponential function. The first one is it must have X as an exponent. The second rule is the base must be positive. The third rule is the base cannot equal 1. And you can't have the base and the exponent with an x. So you can't have base and exponent with an x. Okay, so if it meets all of those, then we can call it an exponential function. All right, next we are going to graph two functions in the same grid. One is 2 to the x, the other one's 1/2 to the x. So I'm going to do a t-chart for both, and this is your basic way you're going to graph these. So y equals 2 to the x. If I choose -3, -2, -1, 0, 1, 2, and 3, put a -3 in there, 2 to the -3 is really 1 over 2 to the third, so that's 1/8. Then that makes this 1/4, 1/2. 2 to the 0 is always 1, and then basically we're just going to be doubling them as we go down. So you can see from top to bottom it's been doubled. So if I draw that, I can 1, 2, 3, 1, 2, 3. So I have -3 and 1/8, which is right about there. -2 and 1/4, not much higher. -1.5. Here's 1, 2, 3 going up. 4, 5, 6, 7, 8. We got to go up to 8. So 1 is, or 0 is 1, then 1 is 2, 2 is 4. Now you can see it start shooting up really quickly. And it's just going to go up faster and faster every time. So let's try the next one. So y equals 1/2. I have x and y. I'm going to pick the same numbers, -3, -2, 1, 0, 1, 2, 3. And this time, if I put a -3, that really means 1 over 1/2, which is 2 to the third. So this is going to be 8, and then we cut everything in half as we go. 1, 1/2, 1/4, and 1/8. Now, if you don't believe me, go ahead and try those all, but just trust me for now, and it's all good. All right, -3, 8 is way up here. -2, 4 is about here. -1, 2 is here. 0, 1 is here. And then 1, 1/2. And then we get smaller and smaller. So we still have this rising very quickly, but it's rising to the left. So we have a little general statement we're going to take from this. If the base, in our case it's the 2 and the 1/2, is greater than 1, it rises to the right. And the bigger the number of the base, the steeper it's going to be. So if that was a 3, it would rise even more quickly. If the base is between 0 and 1, then we say it rises to the left. And this time the bigger means it's going to be flatter. Okay, so just some basic ideas about the graphs so you can kind of check your work as you go. All right, next. Our basic equation, y equals b to the x, can be translated. So we could put a minus c and a plus d in there. The minus c goes with the exponent. The c is going to make it move left, which would be a plus sign, or right, which would be a minus sign, which seems kind of backwards, but that's the way it goes. And d is up, which would be plus, or down, which would be minus. So you can draw the normal blue graph like we just did, and then shift it left, right, up, or down. Or you can just do a t-chart including C and D, and just have that be part of the way you figure it out. So 2 ways to graph it if it's got translations in it. The next thing I want to talk about is the natural base E. Natural base E. E is a number just like pi is a number. Might be not as used to it, but it's used quite often. It is defined by this, 1 plus 1 over n to the nth. Okay, that produces the number e. And as n is approaching very large numbers, or infinity, e is approximately equal to 2.72. Now it's a long decimal that never ends because it's an irrational number. Irrational. It's really like 2.71828187, etc. But we're going to abbreviate it down to 2.72. So try it in your calculator. So try e squared and see what you get. E squared is 2.72 to the second power. You should get approximately 7.389. Okay. Let's think of a real-world example. If in the Western Great Lakes, they have a gray wolf population issue, and there is a formula that says 1066 e to the 0.042 times x represents the population x years after 1978. So maybe they came up with this formula in 1978. So you have to start there. You don't start at 0, you start at 1978. So let's find out the population in 2018. Okay, 2018 is 40 years after 1978. Here we go, 1978. So x is going to be 40. Oops, 40. So up here, let me go in a different color. We're going to use this, but I'm going to put a 40 in there. So 1066 e to the 0.042 times 40. If you work that out on your calculator, comes out to be about 5,719 wolves. So they were very much endangered at one time, so the numbers are coming back slowly. All right, the last thing I want to do is give you some formulas about banking, which uses this number e a lot and the exponential functions a lot. We're not going to do problems with it. We're going to do those tomorrow in class, but just to get you started, first of all, we have compound interest. Compound interest is used every day in every bank. It's A equals P 1 plus R to the T. Let's write down what everything stands for. P stands for the starting principal, which is the starting amount, money. A is the final amount. R is the interest rate, but it has to be as a decimal. Okay, they're not going to give you as a decimal in the problem. You have to turn it into a decimal. And then T is the time in years. Okay, so that is one of them. The next one is compound interest other than once a year. Okay, compound interest other than once a year, and that's A equals P 1 plus R over N, or raised to the Tn. Okay, N is the only thing that's really different here, and N is just the number of times per year the interest is calculated. For example, if you do it monthly, then N would be 12. If you do it quarterly, quarterly means every quarter, every fourth. So N is 4 times a year. Quarterly is every 3 months. So there's lots of different ways. You could do it semi-annually, is twice a year. So you have to pay attention if it's other than just once a year. And the last one, which is probably the best type of interest, is continuous compounded. Continuous compound interest, and that's the A equals P e to the RT. So that means every second of every day they're compounding interest for you. Okay. I think they said every trillionth of a second. So that's really, really fast. So it's basically continuous. And in the book, this is on page 450, so it shows how that's done. So A stands for the final amount, again. P is the starting principal. And R is the rate in decimal. And T is the time in years. Okay, so those are all the formulas we're going to be using. And we'll be graphing a lot in class too. All right, that's it for now. Trig love is everywhere. Grab some.